Now the next topic is the complement rule. What is this complement rule? The complement rule, this says that sometimes what happens, if you want something, then what you can do, you can find from total, you can remove the undesired elements. Yes or no? If you want some elements, then what you can do, from total elements, you can remove the undesired elements. So this is what you can do sometimes. Now, for example, okay, sometimes it is very easy to calculate the undesired cases. I will ask you something, but what I am asking, okay, opposite of that, you can calculate very easily. So sometimes it is easier to calculate the undesired cases. Okay, then what you can do, very easy, to calculate desired cases, what you can do, calculate total cases, from that you remove the undesired cases, so you will get desired cases. So this is called complement rule. So let's take with example. Okay, tell me about this. How many functions from A to B are not injective? Are not injective. I am asking not injective. So my desired. So tell me what is my desired? What is my desire? My desire is not injective. Not injective functions. This is the desired. Okay. So what I will do? What I will do? If I want not injective function, not one function, non-1 function, then that is equal to total functions. That is equal to total functions minus 1 functions. Total number of functions minus number of 1 function, I can say. So minus number of 1 function. So number of total function. So number of non-1 function is equal to this. So what is the total number of function from A to B? A has 3 elements, B has 5 elements. So total number of functions from A to B. A has 3 elements, B has 5 elements. So that will be 5 power 3. And 1 function. How many 1 function we have from A to B? That will be 5 into 4 into 3. We have already found this. Okay, so finally, how many non-1 function will be there? How many functions are not 1. So number of not 1 function, that will be 125 minus 60. So this is going to be your answer. Okay, so this is how you can notice that sometimes total cases minus undesired cases. You can notice in this question undesired cases are easier to calculate, right? Yes or no? In this question, it is easy to calculate 1 function. It is easy to calculate 1 function. So what you can do, very simple. From total function, you can remove 1 functions, number of 1 function. What is the answer for this question? 4-letter words in English alphabet. How many do not begin with L? They do not begin with L. For this question, you can apply 2 methods. You can solve this question. What is method 1? See, method 1 is very simple. Basically, you want 4-letter words. They do not begin with L. So for the first position, how many choices? They do not begin with L. So for the first position, we have 25 choices. And for the second, I have 26. For the third, I have 26. For the fourth, I have 26. So for the method 1, answer will be 25 into 26 power 3. This is your method 1. And what is method 2? Method 2 is not begin with L. It means not starting with L. Is equal to total minus starting with L. Yes or no? Total minus start with L. So how many total we have? Total we have is 26 power 4. And how many will start with start with L? How many will start with L? So that will be 26 power 3. And from this method 2, your answer will be 26 power 4 minus 26 power 3. You can just check it out. What will be the answer? So this will be the same. Okay, so both are same. Method 1, method 2. They are giving you the same answer. You can check. So you can solve this question very easily because not starting with L. So the first letter can be can have for the first letter we can have 25 choices. So you can notice method 1, method 2, they are giving the same answer. Okay, this is interesting question. Tell me, how many students ID have some repetition? Some repetition means at least one repetition. So how many student ID will have at least one repetition? You want at least one repetition. So very simple. If you want some repetition means at least one repetition. So some repetition, that simply means total minus no repetition. From total, if I remove no repetition, what is total? Total is 26 power 3 into 10 to the power 2 minus no repetition. No repetition means 26 into 25 into 24 into 10 into 9. Okay, so this is the idea. So the answer will be this. This is your answer. So some repetition, this is going to be the answer. One more question. Let me ask you. So have some repetition of letter. Some repetition of letter. Some repetition of letter. Okay, now tell me the answer. Again, the method is same. The method is same, that some repetition of letter, that will be equal to total minus no repetition of letter. No repetition of letter. So total you already know, that is 26 power 3 into 10 to the power 2 minus no repetition of letters. Letters should not repeat. So 26 into 24, 25 into 24 into 10 to the power 2. Letters should not repeat. Yes or no? So this is what we have total. And this is what we have when letter is not repeating. Remember, letter is not repeating. Okay. So this is the question. Some repetition of letters. So I can say total minus no repetition of letters. No repetition of letters means the digit can repeat. The digit can repeat. So the answer will be this. Is this clear to everyone? Tell me. Is this point clear? Okay. This is interesting question. So try this. In this question, we have all the three things: sum rule, product rule, and complement rule. So what this question is saying, so you want a password, and this password can be 6 to 8 character long. Okay. And where each character is uppercase letter or a digit. Each password, okay, remember each character is a digit or uppercase letter. Each password must contain at least one digit. How many possible passwords we have? So remember, if you want to create a password, you want to create a password. If you want to create a password, then either you can create 6 length password, or you can create 7 length password, or you can create 8 length password. Tell me, can I directly add them? Are they mutually disjoint? Are they mutually disjoint? 6 length password, 7 length password, they have something common? They have something common? No, nothing common. So this is 6 length, 7 length, 8 length. So either you can do this or this or this. So I can add them. Now, how many 6 length passwords we have? Okay, so remember, each password must contain at least one digit. At least one digit. So at least one digit. Okay, like P6. P6 means P6. This must have at least one digit. At least one digit. So I can say at least one digit. That simply means that total minus no digit. Total minus no digit. And what is total? So total will be 36 power 6. And no digit means 26 power 6. So total, remember, for total, if you want 6, like, okay, you want 6 length password. Your password you want as 6 length. Okay, so how many total how many passwords you can create? So because you are creating 6 length password, so total every character has 36 choices. For every character we have 36 choices for every character. Okay, because you can notice that every character, the question is saying that every character, each character is a uppercase letter or a digit. So I can say that 36. So total will be 36 power 6. And how many have no digit? There is no digit. If there is no digit, it means every character will be uppercase letter. So that will be 26 power 6 because there is no digit. You cannot use any digit. So this P6 will be 36 power 6 minus 26 power 6. Okay. Plus this P7 will be 36 power 7, 26 power 7. And this P8 will be 36 power 8 minus 26 power 8. Okay, so this will be the answer. This is your number of password. Correct? Is this clear to everyone? So in this question, we are using complement rule. This is the complement rule. This is your summation rule. And you can notice that this is your product rule. So in this question, all these three rules we are using. Let's see the next question that is related to cards. That is related to cards. Let's see. So if you want to play a game of cards, you don't have to learn how to play a game of cards. But anyway, this is important that you should know what are the things in a cards game. So in a cards game, let me tell you, there are first of all 52 cards. In a deck, what is a deck? In a deck of cards, in a deck of cards, in a standard deck of cards, I can say, in a standard deck of cards, how many cards we have in a standard deck of cards? There are 4 types of cards. So these suits are basically nothing but types. Okay, so there are 4 types. There is club. In Hindi we call it chidi. Okay, this is a heart. In Hindi you call it pan. This is spades. In Hindi we call it. Can anyone tell me what we call it in Hindi? Spades. That is hukum. Hukum ka patta. Okay, and this is int. You know, diamond. So basically there are 4 type of cards: clubs, hearts, spades, diamonds. Okay, so there are 4 type of cards. So for this, for every type we have 13 cards. So remember, there are 4 type of cards, and for every type we have 13 cards. For every type there are 13 cards. We have total 13 cards, 13 card values. I can say there are 13 card values for every type, and these card values are normally they are from 2, 3, and so on 10, and then there is jack, then there is queen, then there is king, then there is ace. Okay, so this is the idea. So finally you can notice that there are 52 cards. Okay, so total if you calculate, so there are 4 types. For each type there are 13 cards, so total 52. Now let's solve this question. What will be the answer? Now tell me the answer. So what is the total? Now tell me. Remember, you are drawing 2 cards, one after one. You are drawing 2 cards, one after one. Total will be 52 multiplied by 51. Total will be this. For first card we have, so you are drawing 2 cards, one after one. For first card you have 52 choices. For second card you have 51 choices. There is no ace. So for the first card, how many choices? So there are 48 choices for the first one. There are 48 choices for the first one, and there are 47 choices for the second one, because there should be no ace. How many ace cards we have? In this card game, how many cards of ace we have? There are 4 cards of ace we have. Ace is a value. Okay, like jack, queen. Queen is a value. King is a value. For value king, we have 4 cards. Okay, so remember this is a value. Now I can say, so this will be, so finally answer will be this, at least one ace. So that will be, this is the answer. From this you remove this will be the answer. Can we directly apply the product rule? Let's just try to see, can we directly apply product rule? Like without using this complement rule, can we directly apply product rule? So remember, you want 2 cards, one after one. You want 2 cards. Okay, one after one. For the first card, how many choices you have? For the first card, how many choices you have? Okay, let's assume you have 52 choices. Let's assume you have 52 choices. Let's assume. Now for the second card, how many choices you see? For the first card, we have 52 choices. You can draw any of them. For the second card, how many choices you have? For the second card, how many choices you have? Some students are saying 4. Is this correct? Some students are saying 4. Is this answer correct? So can I say answer will be this? What is wrong here? There is something wrong. You want, remember, there should be at least one ace. There should be at least one ace. So is this correct? This thing is wrong. This is clearly, this is wrong. But tell me what is wrong here. This is clearly wrong. But I just want to know what is wrong here. Let me tell you what is wrong here. Okay. If you apply like this, so for the first, okay, just understand this very carefully. Just understand this. What you are doing, you are saying that for the first card, we have 52 choices. For the first card can be anything, right? Agree or not? First card can be anything. Do you agree? First card can be anything, right? Okay. So for the first part, card, you have 52 choices. Okay. So there is no problem. There is no problem. You have 52 choices. But the problem is with the second card. Let me tell you. Let me tell you what is the problem with second card. If you directly say 4, that is wrong. Why that is wrong? Just think about it. Just think about it. If these 52 cards, okay, I'm selecting one of those. Okay, so there are 52 ways. But tell me, if the first card, a card I select as, let's assume Jack. Let's assume I select as Jack. Okay, like this. Okay, Jack of diamond. Let's assume I select Jack of diamond. Now tell me how many choices for the second. Now tell me how many choices for the second. If the first card is Jack of diamond, then for the second, now 4 choices. Now 4 choices. But just understand this. If the first card is ace of diamond, remember, for the first card you have 52 choices. For the first card you have 52 choices. First card can be anything. Okay. Now if the first card is, let's assume, because there are 52 choices, so the first card can be diamond ace, right? Agree or not? Is it possible? Yes, because for the first card you have 52 choices. So the first card can be this. Now tell me how many choices for the second card. Now how many choices for the second card? Now it can be any of the 51. So can you notice what is the problem here? Can you apply the product rule in this type of situation? Can you apply the product rule? So the product rule you cannot apply, because remember, product rule, very important thing. If anyone understands this, then almost 90% these combinators you will understand if you understand this. In product rule, remember, you have two tasks. You have two tasks T1 and you have two tasks T1, T2. Remember this point, that for every way in this T1, whatever way you do, for example, let's assume there are m ways. Okay. And remember these n ways, however you do T1, remember, however you do T1, there are n ways. Please understand this. However you do T1, there are n ways. Okay. However you do T1 it means that this T1 you can do in m ways. In whatever way I do T1, in whatever, that is my choice, in whatever way I do T1, in whatever way we do T1, there should be, for every way, in whatever way you do, okay, we do T1, there should be n ways for T2. Are you getting this point? Please tell me. So this T1, whatever way you do, there should be n ways for T2. Like remember, it should not happen that for different ways you are getting different values here. It should not happen. Whatever you put here, there should be fixed n ways. For example, like 5 letters without repetition. 5 letters without repetition. This is your example. 5 letters without repetition. Now you can notice that Now you can notice there, here we have 26 ways, correct? But remember one thing, very important. Whatever I put here, whatever, like A, B, C, D, X, Y, Z, whatever I put here, tell me how many ways. Tell me how many ways. Whatever I put here, whatever I put here, now how many ways? 25 ways, right? So you can understand that. You can understand this is T1, this is T2. You can see that this T1, whether you put A, then also this T2 have 25 ways. If you put A, then there are 25 ways. If you put B, then there are 25 ways. If you put C, then there are 25 ways. If you put Z, then there are 25 ways. So whatever you do, okay, in whatever way you do T1, in whatever way you do T1, okay, there are n ways for T2. So you can notice in whatever way I do T1, this T1 I can do in this way, there are 25 ways. In this way, there are 25 ways. So in every way, there are 25 ways. So finally, here you can apply product rule, and the product rule will give you answer 26 into 25. But here, can you apply product rule? In this case, can you apply the product rule? In this case, can you apply the product rule? So here you cannot apply the product rule, because for different ways, if I put this here, just notice, if I put this here, then there are 4 ways, and if I put this here, then there are 51 ways. So you cannot apply product rule directly. Okay, so because of this and this, because of this I can say, so this answer is wrong. So this is wrong answer. But this question you can solve by cases. Remember this same question, this drawing 2 cards, this same question you can solve by cases. How will you solve by cases? Okay, so the same question, basically you are drawing 2 cards, one after one. Order matters. Okay, so at least one ace, containing at least one ace. Now for this question, actually you can create cases. What are the cases? This question you can solve by cases. What is the cases? Can I create these 2 cases and tell me, are they mutually exclusive? Like here I am saying that this is ace, and here I am saying that this is ace. Are they mutually exclusive? Are they mutually exclusive? Are they mutually exclusive? Containing at least one ace. At least one ace must be there. Remember, at least one ace must be there. Remember here, this case 1, 2, these are not mutually exclusive. If you do like this, then this is wrong. Okay, see, if you say that this case 1, for this case 1, let's assume you are saying, so remember this case 1 and this case 2, these are not mutually exclusive. Not mutually exclusive. Because what you can do, see, if the first card is ace, second card also can be ace. If the second card is ace, first card also can be ace. So you can notice they are not mutually exclusive, these 2 cases. So you should create mutually exclusive cases. Remember, these 2 cases are not mutually exclusive. So what cases I should create? Tell me. Can anyone tell me what cases I should create? Yes, I should create cases like this. That case 1 is first card is ace, second card is non-ace. Okay, like this I can create. What I can say first card is ace and second card is non-ace. In case 2, what I can do? I can do first card is non-ace and second card is ace. And case 3 will be both cards are ace. Agree? Both cards are ace. So this is the idea. Now tell me, now are they mutually exclusive? Case 1, case 2, case 3. Are they mutually exclusive? Yes. Now you can notice that they are mutually exclusive, and are they exhaustive? Did we cover all the possibilities? Did we cover all the possibilities? Yes, we have covered all the possibilities because we want at least one ace. And you can notice we have covered all the possibilities. Now tell me what is the answer for case one. Okay, the first card should be ace. So four choices. Four choices for ace. I can say four choices for this. And four, and okay, once you have this, then how many choices for non-ace? 48 choices for non-ace. Similarly here, there are 48 choices for non-ace and there are four choices for ace. And here we have four choices for this, three choices for this. So your answer will be summation of these. So this is your method number 2. So you can do like this also. Is this clear to everyone? So like this also you can do. If you create these cases, then you have to remove the cases when both are ace. See, if you do like this, then what you have to do? If you create cases like this, then what you will have to do? So let's assume you are creating cases like this. Now what you will have to do? If I create these cases, so like someone is creating these cases, ace anything. Okay, case 2, anything ace. If you create these two cases, then there is something common. What is something common? So tell me what is something common? Ace, ace. This is common. There is something common you can notice. Yes or no? So in these two cases, here you are putting ace, anything else, anything ace. So the common thing will be that, okay, this is also ace, this is also ace. So in this situation, answer will be what? In this situation, answer will be 4 multiplied by 51 plus. So this is your case 1. Case 1 is 4 multiplied by 51 plus. Case 2 is what? Case 2 is 4 multiplied by 51. In case 2, what you can do? First, okay, in case 2, first you can put here and then you can put here. In case 2. So in case 2, you will have 4 multiplied by 51 because here you have 4 choices and here you have remaining choices. Okay, and minus 4 multiplied by 3. Okay, so this will be your answer. Can you check 3 methods we have seen? For the same question, we have seen 3 methods. So method 1, what is the answer method 1 gave us? What answer we got by method 1? I think we got this answer. Minus 48 into 47. This method 1 gave us this answer. Method 2 is giving us this answer. That, okay, 4 into 48 into 2 plus 4 into 3. And method 3 is giving us this answer. So 3 methods we have seen for the same question. Minus 4 into 3. Are they same? Can you check? Like, please check whether they are same or not. All these 3 answers, are they same? Just check, just calculate all of them. 396, right? So this will be 396. And what that this will be? So this also will be 396. And I think this also will be 396. Okay. Anyway, the same question you can do by 3 different methods. Is this clear to everyone? Tell me. But remember the product rule. Okay, please remember this point, that product rule. When you apply the product rule, then you should take care. This thing you should take care. Whatever way you do T1, in every way there should be n ways for T2. Okay, like this. Like in whatever way you do A to Z, in every way you have 25. In every way you have 25. So in this situation, you can apply the product rule. Okay, let's move on. Let's solve this GATE exam question. This is your GATE 2021 question. Can you try? This is on product rule. So what is the answer for this? So how many n by n matrices with entries from this set? How many n by n matrices you can create? So what is the card? So basically find the cardinality of S1 and find the cardinality of S2. But this is the question. So S1 is saying how many n by n matrices you can create such that entries, every entry will be coming from ABC. So tell me, you want to create n by n matrices. These n by n matrices you want to create, and every entry should come from ABC. Every entry should come from ABC. So for example, this entry can be A. Okay, for example, this entry can be A. For example, this entry can be B. For example, this entry can be C. For example, this entry can be B, something like this. Okay, so this is the idea. So finally, I can say that for every position in this, how many positions you have in this matrix? You have n square positions in this matrix. N square position. For every position, you have 3 choices. Okay, for every position, you have 3 choices, and there are total n square positions. Yes or no? Whatever position you take, there are 3 choices, and total we have n square positions. So for every position we have 3 choices. Like for this position we have 3 choices. Okay, so I can say these 3 positions for this position also. So this is your S1, and next is S2. What is that? How many functions from this set to this set? How many functions in this set? How many elements we have in this set? Total how many elements we have? N square. And in this set, how many elements? 3. So number of functions, what that will be? So remember, okay, basically number of functions from, so I can say from A to B, where cardinality of A is n square and cardinality of B is 3. So number of functions, that will be 3 power n square. Okay, and this is your number of matrices. So how many matrices you can create this? Anyway, this is your GATE 2021 question. Okay, let's see this. Okay, quickly tell me what is the answer for this question. How many 4-digit pin codes not starting with 0? This question is very easy. How many 4-digit pin code? They should not start with 0. So because they should not start with 0, so 9 choices. Now we have 10 choices, 10 choices, 10 choices. Okay, so this is very easy. What about this? Solve this question. One tricky question is coming on your way. It is going to come. So tell me this. 4-digit numbers not starting with 0. It also should be odd number. It must be odd number, and it should not start with the 0. It should not start with 0. So it should be odd number. And without repetition, and you should not have a repetition. Okay, so let's start. For here, how many choices? Just tell me how many choices I have for this position. For this position, I have 9 choices. Okay. For this position, how many choices? For this position, how many choices? For this position, remember, no repetition, 9 choices, because I cannot use what you put here. For this position, how many choices? 8. For this position, how many choices? 5. For this position, this must be odd number, right? This must be odd number. Is this correct answer? This should be odd number. This should be odd number. So here we have only 5 choices. Is this correct answer? Is this answer correct? What is wrong here? This answer is very utterly wrong. Let me tell you, wrong answer. And what is wrong here? Because see, these choices will depend on what you put here. Agree or not? See, it will these choices will depend on what you will put here, because you are not having any repetition. See, why this is wrong? Let me tell you. Just think about it. This is wrong because here you are saying no 9 choices. You are saying, I am not saying, you are saying that here we have 9 choices. So let me put 5. Let me put 5. Okay, let me put 5. Now tell me how many choices here. Now tell me how many choices. Let me put 5 here. Now I have 9 choices. You cannot put 5. So let me put 0. How many choices here? How many choices here? 8 choices you are saying. So let me put 3. Now tell me how many choices here. Please tell me now. Now tell me how many choices. Now only 3, right? So can you notice the mistake? Please tell me the mistake. What is the mistake you are making? What is the mistake? This is the mistake, right? Okay, is this correct? Did you understand that you did you understand the mistake? This answer is wrong, but did you understand why it is wrong? Why this answer is wrong? Now let me give you one guideline. Okay, this is a guideline, and guideline number 1. In your house, okay, if there is a stubborn child, okay, let's assume there is a very stubborn child, okay, and you are bringing some maybe biscuits or chocolates, and that child is very stubborn. You know that if he does not get what he wants, then he will cry whole night. Then what will you do? What will you do? You will start with him, right? You will start with him. You will tell him, okay, first you take, like first you take, give him first, right? Yes or no? So that is the idea. That is the same idea here. Guideline number 1. Start with the most restricted place. Start with the most restricted place. Restricted place. Remember, this is a guideline. This is not a theorem. Can you notice this is not a theorem? So what it means, if it is a guideline, what it means? It means you should take care. It means in most situations, this will work. In many situations, this will work. But I am not saying that this is a theorem. It will not work always. You should apply your analysis. So that is the reason we are doing a lot of analysis, a lot of variations we are doing. For every question, I am doing many variations I am creating so that you can see what is happening. Okay, so this is a guideline. This is not a theorem. So you should take care. Okay, anyway, start with the most restricted place while applying product rule. While applying product rule or any rule, actually, most of the time, while applying product rule or any rule, most of the time, you should start with the most restricted place. So here, this answer is wrong. What is the correct answer? So what is going to be the correct answer? So you start from here because you want odd number. So from here you start. Let's call it T1. Let's call this T1. Okay, so here you have 5 choices. First you give him, okay, what he wants. So first you give him odd number because this should be odd number. First you give him. Now the next restricted place. Now go to the next restricted place. Now this is your T2, the next restricted place. Now what should I give him? What should I give him? So I should, okay, 3 I cannot give, 0 I cannot give. There are total 8 choices. I cannot give 3, I cannot give 0. Now I can give anything else. For example, I can give 6. Now I have these 2 things I cannot use. So again, I have 8 choices. Now I can give, for example, 5. And here I can use it 0. So this is correct answer. Is this clear? So this answer is correct. Because you can notice we are having an odd number. Okay, and now this answer is correct. So this answer is correct. 8 into 8 into 7 into 5. So this is a guideline. So let's start with this. What is going to be the answer? The number must be even number, not starting with 0. So let's start with the most restricted place. So let me put it, okay, this is your T1. So there are only 5 choices here. Now the next restricted place is this. So let me put, for example, let me put 8. Okay, there are 5 choices here. Now, how many choices I have here? How many choices? So you can notice there are 5 choices for this position. How many choices I have here? For this position, I have 5 choices. Now, how many choices I have here? Can you tell me? For this, I have 5 choices. How many choices I have here? It will depend on what you are putting here. Yes or no? Please. It will depend on what you are putting here. It will depend on what you are putting here. If I put 0 here, then there are 9 choices. If I put 0 here, see, if I put 0 here, then there will be nine choices. Then there will be 9 choices. So if I put 0 here, then there will be 9 choices. And if I put 2 here, then there will be only 8 choices. So can you notice that there is something going on? There is something going on. Okay, so this answer will be wrong. If you do like this answer will be wrong. If you do like, for example, 5 choices here, this is your T1, this is your T2. Okay, 9 choices will be here. And then there will be 8 choices, 7 choices. This answer will be wrong. So finally, answer will be what? Now, what should we do? By cases. See, whenever you are in trouble, do by cases. This cases, by cases, this is very very good method. This is a very helping method. Whenever you are in trouble, once you think about by cases, okay? So just that is my idea. Okay, so let's see what are the by cases. So how many cases you can create? Case 1, case 2. What is the problem here? The problem you can do, okay, with respect to 0. In case 1, you are putting 0 here. And in case 2, you are putting non-zero here. In case 2, you are putting non-zero here. These, okay, are they mutually exclusive cases? These 2 cases, are they mutually exclusive? Are they mutually exclusive? Yes. So finally, what you can do, if you put 0 here, how many choices? If you put 0 here, then 9 choices. If you put 0 here, then 9 choices. Now you can put, okay, like, okay, you can put anything you want here. You can put anything. So finally, there will be 8 choices and there will be 7 choices. So here you will have 9 into 8 into 7. And here what you will have? So for this, you have total 4 choices. There are total 4 choices because you cannot put 0. This 0 you cannot put here. Now how many choices here? You cannot put 0, you cannot put 2. So there are 8 choices. And now what? Okay, now you can put, so whatever you put here, for example, let me put maybe 3. Now I can put 8 choices. Now I can put 0. There is no problem. And for this also there are 7 choices. So what is the answer? So this will be 8 into 8 into 4 into 7. Okay, 8 into 4 into 7. And plus this. If you add both of them, your answer you will get. Your answer will be this plus this. Is it clear to everyone? Tell me. These are some questions for your practice. Please take this as a homework. We have already done this. This is your GATE 2001 question. This we have done right now. I think 2296, right? Okay, so this answer we got. How many elements in A cross B? You already know. So if you have 2 sets, so let's assume you have a set A and there is a set B. In this set A, let's assume there are n elements. In this set A, means cardinality of A is M and cardinality of B is n. Then how many elements in A cross B? In A cross B, we have ordered pairs. We have ordered pairs where the first element comes from A, second element comes from B. So remember this first element. So these order, how many ordered pairs? The question is asking. So we need to create ordered pairs. Remember, we need to create ordered pairs. This is our task. We need to create ordered pairs. How many ordered pairs we can create? This is our task. So you want to create ordered pair. Okay, so I can call it task T1, I can call it task T2. For T1, how many choices? For T1, here I can put any element of A. First element will come from A. I can put any element of A. For task T2, I can put any element of B. I should do T1 and T2. I should do T1 and T2. So answer will be M into N. Answer will be Mn. Because I should do T1 and T2. So this is a product rule. So the cardinality of Cartesian product. Okay, so these are some questions. One more guideline will come. One guideline we have seen, guideline number 1. What is that? Start with the most restricted place. That is guideline number 1. And we have seen what is wrong with some questions, product rule. Now let's see this. You are doing a web check-in for your flight to book a seat. Among the available seats, there are 30 free middle seat, 20 free window seat, and 10 paid seat you have. These are available seats. Now you do not have any money. How many ways you have to book one seat for yourself? What is the answer? You do not have any money. You want to book as one seat. So what is the answer? So you can book the free seat, right? Yes or no? These are the available seat. So these 3 free seat, or you can use window seat. So only 50 seats are available. 30 free seat middle seat and 20 free seat window seat. Only these are available. So only 50 seats are available for you. How many ways? Only 50 ways are there. Okay, tell me about this one. You do not have any money, the same scenario, but there is one condition. Like, okay, there are 3 people and you are saying that how many ways you can book one seat for you, for yourself, if 2 free seats are already booked by your brother and sister before you are doing your booking. Now, so now the answer will be, now 2 seats are already taken. Because 2 seats are already taken, so the answer will be this minus 2. Okay, answer will be 42, 48. Okay, and what about this? So you do not have any money, and if 2 paid seats are already booked by your brother sister, basically you do not have a money, you don't have any money, but your brother sisters are very rich, so they have booked 2 paid seats, they have booked for themselves. So what is the answer? Again, answer is 50. Again, answer is 50 because they booked the paid seat. So you can take anything. Okay. So guideline number 2. Can you notice that in these questions, if you notice, some information is extra. In these questions, like some information is extra. For example, in this question, you are not using this information, this 10 paid seat. This information we are not using. So this I have seen actually many times. Many students, what they do, if some information is given in a question, they will try to use it. Somehow they will try to use it. See, just because some information is given, it does not mean it is useful. Read the question carefully and answer it. I have seen this many times. Okay, like some information is given and somehow a student will try to use it. Like, okay, how this information is given, I will use it. Whatever, like they do not care what is asked or not, they will just try to use it. Okay, so don't do this. Just because some information is given, it does not mean it is useful. Okay, what about this? You do not have money, 2 seats you have to book for you and your sister. For you and your sister, 2 seats you have to book for you and your sister. This is you and this is your sister. So for you, what you can do, there are 50 choices for you and there are 49 choices for your sister. So the answer will be 50 into 49. Very simple. Okay, let's move on. Quickly tell me what is the answer for this. You have set A, B. Set A has cardinality 3. Set B has cardinality 5. How many functions from A to B such that A maps to T? This information is already given to you that A is mapping to T. Remember, A is already mapping to T. So here you have A, B, C, and here you have X, Y, Z, W, T. And this is given that A is already mapping to T. This is given. Now you can notice for this only one choice you have because it is already mapping to T. For B, we have 5 choices. For C, we have 5 choices. So here the answer will be 5 into 5. That will be 25. Okay, so there are 25 functions. Correct? Because A does not have any choice, but B, C, they have choice. What about this question? A is mapping to T, B is mapping to X. Now only C has choice. A is already mapping to T, and B is already mapping to X. So C has choice. For C, we have total 5 choices. So here the answer will be 5 for this question. And now there is a gate question. Before that, just tell me about this one. How many 1-1 function we have? How many 1-1 function? A is mapping to T, B is mapping to X. So A is mapping to T, B is mapping to X. How many 1-1 function? For C, we have only 3 choices. Only 3 choices we have. So for this question, answer will be 3. For this question. Okay. And this is your GATE 2021 question. So tell me the answer for this. GATE 2021. There are 6 jobs with distinct difficulty levels. Means different. 6 jobs, they have different difficulty level. 3 computers with the distinct processing speed. Okay. Each job is assigned to a computer such that the fastest computer gets the toughest job, the slowest computer gets the easiest job, every computer gets at least 1 job. The number of ways this can be done. How many ways this can be done? This is your GATE 2021 question. How many ways this can be done? So there are 6 jobs with different difficulty level. There are 6 jobs. Okay, there is J1, there is J2, there is J3, there is J4, there is J5, there is J6. They have different difficulty level. Let's assume this is the difficulty level. Let's assume. So this is the easiest. J1 is the easiest. 3 computers you have with a distinct processing speed. C1, C2, C3. They have different processing speed. The fastest computer gets the toughest job. So tell me, for this job J1, how many choices you have? For this job J1, how many choices you have? Only 1 choice. This will go to the easiest computer. There is no choice for J1. There is no choice for J6. There is no choice. No choice for J1, J6. Every computer gets at least 1 job. So there is no choice for J1, J6. You can remove them. Forget about them. Okay. Do not worry about J1, J6. Now tell me. Now what we have to do? Now this is every computer gets at least 1 job. Already C1 is getting at least 1 job, right? Already C1 is getting at least 1 job. Already C3 is getting at least 1 job. So what we need to do? It simply means that C2 should get at least 1 job. Already C1 has at least 1 job. Already C3 has at least 1 job. So it means this line means C3, sorry, this line means C2 should get at least 1 job. So I can say that, okay, remember C2 should get at least 1 job. At least 1 job to C2. At least 1 job to C2. This is equal to total minus no job to C2. No job to C2. What is total? Total is what? Every job has, see, J2 has 3 choices, right? J2 has 3 choices. J2 has 3 choices. J3 has 3 choices. J4 has 3 choices. J5 has 3 choices. Okay, so total will be 3 power 4 minus no job to C2. It means 2 power 4. It means 2, 2, 2. Okay, so 2 power 4. Yes, so the answer will be 3 power 4 minus 2 power 4. This will be your answer. So tell me, is this clear to everyone? So this is a simple question. How 2 power 4? Because no job to C2. You are not giving any job to C2. It means all the job are going to C1 or C3. Yes or no? Every job is going, for every job, if you are not giving any job to C2, it means every job has 2 choices. Yes or no? Is this clear? No job to C2. It means every job, okay, it means J2 to J4. J2 to J4. They have two choices. They have 2 choices each. They have 2 choices each. Each of them have 2 choices. Okay, so this is the idea. So the answer will be 3 power 4 minus 2 power 4. Very simple.